Coding for a Cleaner World has been designed as a task to target the large amounts of rubbish entering local environments, such as parks and waterways, due to human activities. To help raise awareness of this problem, our task involves Year 4 students creating a digital game aimed at educating prep students about caring for their local environment. Students have previously used Scratch Junior, however this will be their first time using Scratch. This task will enhance the students' knowledge of coding and computational thinking, as it has been designed around the 4 cornerstones. Students use pattern recognition skills to look for similarities among and within coding sprites. Students will make one code and repeat the pattern with other sprites, while simultaneously making adjustments where needed. This is particularly evident in Lesson 1, where the students are coding the litter sprites. Students use pattern matching to repeat the code for the litter sprites whilst making adjustments to the size, speed and score of each sprite. Students use decomposition skills to break down a complex problem or system into smaller, more manageable parts. For example, in Lesson 2, students create a timer for the game which counts down from 10 to 0. Students need to understand the different components that form the coding block for the timer. In particular, the timer's coding block requires the time variable to be set to 10 when the flag is clicked, which then reduces the time by 1 second and stops all scripts once the time is finished. Students use abstraction skills to devise a solution to a digital problem. In Lesson 3, students are posed with a digital problem, whereby their game displays well done for a score above 20 and try again for a score below 20. However, students are striving to determine the error in the code to create the condition for success, where the score is equal to 20. Students use a combination of small group and whole class discussions to determine the specific details of the problem posed. Students then use this information to make informed decisions and to identify the error in the code. From this, students are then able to make adjustments to the coding areas and create correct conditions for success. Students use algorithms to build coding blocks following a clear and logical sequence of steps for their sprites, such as characters and litter sprites, which contain variables such as time and conditions for success, such as scores for winning outcomes. Students will be given opportunities to problem solve and troubleshoot their algorithms through managed and unmanaged failures, such as in Lesson 3 when identifying the coding error. Throughout the lessons, students will use computational thinking and decomposition to break down problems into smaller parts and then plan out how they will fit back together in a suitable order to solve the problem. For example, in Lesson 4, students will learn how changes to algorithms affect the outcome of the game to win or lose. For instance, by extending the time condition from 10 seconds to 20 seconds, players are more likely to experience a winning outcome. This activity has a number of cross-curricular applications, particularly to STEM. This activity is connected to science as students examine human impact on the environment in terms of pollution and moreover what they can do to minimise litter through educating others in sustainability. This activity is connected to maths as students develop their number sense through scores and understanding of patterns, time, chances and probability and X and Y axes. This activity is connected to engineering as students are designing a digital product that meets personal, skill and community needs for pollution reduction and sustainability using entrepreneurial skills such as problem solving and troubleshooting.